Polynomial. What is polynomial? A polynomial is the finite expression having one or more terms. It can be constructed using the operations of addition, subtraction, multiplication, and non-negative integer exponents of variables. For example, 5x cubed minus 4x squared plus x minus 2 is a polynomial consisting of components such as terms, variables, exponents, and operators. Types of polynomials. A polynomial having 1, 2, and 3 terms have special names called monomial, binomial, and trinomial respectively. Polynomial having one term is called monomial, having 2 terms is binomial, and having 3 terms is called trinomial. If p of x is a polynomial in x, the highest power of x in p of x is called the degree of the polynomial p of x. Degree of a polynomial. Linear polynomial. A polynomial of degree 1 is called a linear polynomial. The general form of quadratic polynomial is ax plus b, where a and b are real numbers and a is not equal to 0. For example, 2x minus 3, root 3, x plus 5, y plus root 2, x minus 2 by 11, 3z plus 4, 2 by 3u plus 1, etc. Quadratic polynomial. A polynomial of degree 2 is called a quadratic polynomial. The name quadratic has been derived from the word quadrate, which means square. The general form of quadratic polynomial is ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. For example, 2x squared plus 3x minus 2. Cubic polynomial. A polynomial of degree 3 is called a cubic polynomial. The general form of cubic polynomial is ax cubed plus bx squared plus cx plus d, where a, b, c, and d are real numbers and a is not equal to 0. For example, 2 minus x cubed, 3x cubed, minus 2x squared plus x minus 1, etc. Since polynomials are used to describe curves of various types, people use them in the real world to graph curves. For example, roller coaster designs may use polynomials to describe the curves in their rides. Consider p of x is equal to x squared minus 3x minus 4. Put x is equal to 2, therefore p of 2 is equal to 2 squared minus 3 into 2 minus 4, that is equal to minus 6. The value of x squared minus 3x minus 4 at x is equal to 2 is minus 6. If p of x is a polynomial in x and if k is any real number, then the value obtained by replacing x with k in p of x is called the value of p of x at x is equal to k and is denoted by p of k. We will find the values of p of x at x is equal to minus 1 and x is equal to 4. Therefore, p of minus 1 is equal to minus 1 squared minus 3 into minus 1 minus 4 is equal to 0. Also, p of 4 is equal to 4 squared minus 3 into 4 minus 4, that is equal to 16 minus 12 minus 4 is equal to 0. As p of minus 1 is equal to 0 and p of 4 is equal to 0, minus 1 and 4 are called the zeros of the quadratic polynomial x squared minus 3x minus 4. More generally, a real number k is said to be a zero of a polynomial p of x if p of k is equal to 0. In general, if k is a zero of p of x, then p of k is equal to ak plus b, that is equal to 0. That is, k is equal to minus b by a. So the zero of the linear polynomial ax plus b is minus b by a is equal to minus constant term upon coefficient of x. Thus, the zero of a linear polynomial is related to its coefficients. Note, a quadratic polynomial can have at most 2 zeros and a cubic polynomial can have at most 3 zeros. Geometrical meaning of the zeros of a polynomial. For any quadratic polynomial ax squared plus bx plus c, where a is not equal to 0, the graph of the corresponding equation y is equal to ax squared plus bx plus c has one of the two shapes, either upon upwards like this or open downwards like this, depending on whether a is greater than 0 or a is less than 0. For example, if we locate the points listed above on a graph paper and draw the graph, it will look like this. We can see that -1 and 4 are zeros of the quadratic polynomial. Thus, for any quadratic polynomial ax squared plus bx plus c, where a is not equal to 0, the zeros of a quadratic polynomial are precisely the x coordinates of the points where the parabola representing y is equal to ax squared plus bx plus c intersects the x-axis. Case 1. Here, the graph cuts x-axis at two distinct points, A and A. The x-coordinates of A and A1 are the two zeros of the quadratic polynomial ax squared plus bx plus c in this case. Case 2. Here the graph cuts the x-axis at exactly one point, that is, at two coincident points. So the 2 points A and A1 of case 1 coincide here to become one point A. The x-coordinate of A is the only zero for the quadratic polynomial ax squared plus bx plus c in this case. Consider the cubic polynomial x cubed minus 4x. To see what the graph of y is equal to x cubed minus 4x looks like, let us list a few values of y corresponding to a few values for x. We see from the above table that -2, 0 and 2 are zeros of the cubic polynomial x cubed minus 4x. Observe that -2, 2 and 0 are in fact the x-coordinates of only points where the graph of y is equal to x cubed minus 4x intersects the x-axis. Since the curve meets the x-axis in only these 3 points, their x-coordinates are the only zeros of the polynomial. Remark. In general, given a polynomial p of x of degree n, the graph of y is equal to p of x intersects the x-axis at most n points. Therefore, a polynomial p of x of degree n has at most n zeros. So you can see geometrically there a quadratic polynomial can have either two distinct zeros or two equal zeros, that is 1 0 or no zero. This also means that a polynomial of degree 2 has at most two zeros. Look at the graphs given below. Each one is the graph of y is equal to p of x, where p of x is a polynomial. For each of the graphs, find the number of zeros of p of x. Solution. 1. The number of zeros is 1 as the graph intersects the x-axis at one point only. Cubic polynomial. 2. The number of zeros is 2 as the graph intersects the x-axis at 2 points. Quadratic polynomial. 3. The number of zeros is 3. Cubic polynomial. 4. The number of zeros is 1. Linear polynomial. 5. The number of zeros is 1. Quadratic polynomial. 6. The number of zeros is 4. Cubic polynomial. Relationship between zeros and coefficients of a polynomial. In general, if alpha and beta are the zeros of the quadratic polynomial, p of x is equal to ax squared plus bx plus c, a is not equal to 0, then you know that x minus alpha and x minus beta are the factors of p of x. Therefore, ax squared plus bx plus c is equal to k into x minus alpha into x minus beta, where k is a constant, is equal to k into x squared minus alpha plus beta into x plus alpha beta is equal to kx squared minus k alpha plus beta x plus k alpha beta. A. If alpha and beta are the zeros of the quadratic polynomial ax squared plus bx plus c, then alpha plus beta is equal to minus b by a. Alpha beta is equal to c by a. For example, find a quadratic polynomial, the sum and product of whose zeros are minus 3 and 2 respectively. Solution. Let the quadratic polynomial be ax squared plus bx plus c and its zeros be alpha and beta. We have alpha plus beta is equal to minus 3 is equal to minus b by a, and alpha beta is equal to 2 is equal to c by a. If a is equal to 1, then b is equal to 3 and c is equal to 2. So one quadratic polynomial which fits the given conditions is x squared plus 3x plus 2. For example, find the zeros of the quadratic polynomial x squared plus 7x plus 10 and verify the relationship between the zeros and the coefficients. Solution. We have x squared plus 7x plus 10 is equal to x plus 2 into x plus 5. Either x plus 2 is equal to 0 or x plus 5 is equal to 0. That is, when x is equal to minus 2 or x is equal to minus 5. Therefore, the zeros of x squared plus 7x plus 10 are minus 2 and minus 5. Now, sum of zeros is equal to minus 2 plus minus 5 is equal to minus 7 is equal to minus 7 upon 1 is equal to minus coefficient of x upon coefficient of x squared. Product of zeros is equal to minus 2 into minus 5 is equal to 10 is equal to 10 upon 1 is equal to constant term upon coefficient of x squared. In general, for a cubic polynomial, it can be proved that if alpha, beta, gamma are the zeros of the cubic polynomial ax cubed plus bx squared plus cx plus d, then alpha plus beta plus gamma is equal to minus b by a. Alpha beta plus beta gamma plus gamma alpha is equal to c upon a. Alpha beta gamma is equal to minus d by a. For example, verify that 3 minus 1 minus 1 upon 3 are the zeros of the cubic polynomial px is equal to 3x cubed minus 5x squared minus 11x minus 3, and then verify the relationship between the zeros and the coefficients. Solution. Comparing the given polynomial with ax cubed plus bx squared plus cx plus d, we get a is equal to 3, b is equal to minus 5, c is equal to minus 11, d is equal to minus 3. To find p of 3, substituting 3 in x, we get p of 3 is equal to 3 into 3 cubed minus 5 into 3 squared minus 11 into 3 minus 3, that is equal to 81 minus 45 minus 33 minus 3 is equal to 0. P of minus 1 is equal to 3 into minus 1 cube minus 5 into minus 1 squared minus 11 into minus 1 minus 3 is equal to minus 3 minus 5 plus 11 minus 3, which is equal to 0. P of minus 1 by 3 is equal to 3 into minus 1 by 3 cube minus 5 into minus 1 by 3 minus 3. That is equal to minus 1 by 9 minus 5 by 9 plus 11 by 3 minus 3. Solving it further, we get P of minus 1 by 3 is equal to 0. Therefore, 3 minus 1 and minus 1 upon 3 are the zeros of 3x cubed minus 5x squared minus 11x minus 3. Division algorithm for polynomials. If p of x and g of x are any two polynomials where g of x is not equal to 0, then we can find polynomials q of x and r of x such that p of x is equal to g of x into q of x plus r of x, where r of x is equal to 0 or degree of r of x is less than degree of g of x. This result is known as the division algorithm for polynomials. For example, find all the zeros of 2x raised to 4 minus 3x cubed minus 3x squared plus 6x minus 2 if you know that two of its zeros are root 2 and minus root 2. Solution. Since two zeros are root 2 and minus root 2, x minus root 2 into x plus root 2 is equal to x squared minus 2 is a factor of the given polynomial. Now, we divide the given polynomial by x squared minus 2. First term of dividend is 2x raised to 4 and first term of divisor is x squared. So, taking the quotient 2x squared multiplying it with x squared minus 2, we get 2x raised to 4 minus 4x squared. Subtracting the like terms, we get minus 3x cubed plus x squared plus 6x minus 2, taking minus 3x in the quotient, minus 3x multiplied by x squared, minus 2 gives minus 3x cubed plus 6x. After subtracting, we get x squared minus 2, continuing further to get a remainder 0. Therefore, 2x raised to 4 minus 3x cubed minus 3x squared plus 6x minus 2 is equal to 2x squared minus 3x plus 1, x squared minus 2 plus 0. Factorizing 2x squared minus 3x plus 1 as 2x minus 1 into x minus 1. Therefore, 2x minus 1 is equal to 0, or x minus 1 is equal to 0, or x squared minus 2 is equal to 0. That is, x is equal to 1 by 2, or x is equal to 1, or x is equal to plus or minus root 2. Therefore, the zeros of the given polynomial are root 2, minus root 2, 1 by 2 and 1.